Okay, so now that we have created a linear regression model using our skin cancer data, let's take a look at some more pieces of information that we can obtain from that model besides the slope. We already talked about the fact that the slope is the second coefficient here. The first coefficient here is called the intercept. That is the place where, if we come back to our little plot here, that is the place where that line would cross 0 on the y-axis. Now, zeros doesn't show here because you do not have any part of the United States at latitude 0. But if it did show, then where we would cross on the y-axis would be the intercept. Oftentimes, the intercept is not within the range of our data, as is the case here, and the intercept is not all that meaningful. The slope is really the primary coefficient that we're interested here, just this second coefficient, B1. All right, but in addition to the slope, there's some other data that we can get out of this. Let's talk about types of deviations. So there are 3 types of deviations, and when we say deviation, of course, we're thinking of a difference. So the first type is the total deviation, which is the difference between a score and the mean of scores. You could also call this the deviation from the mean. And we see that right down here. That's the observed value minus the mean. You'll remember that when you calculate variation statistics with a set of data, that you start by taking deviations from the mean. So if I'm going to calculate the variance or the standard deviation, I'll take all the deviations from the mean, square each one of those, and then end up taking a sort of average, and for the standard deviation, we take the square root. So we're not going to go back and review all that right now, but the point is that this is some indication of how much variation there is in the data when you look at all those different deviations. Well, what we're hoping to do now is to explain some of that deviation from the mean, that is, explain some of that variation with our x variable. And so we can explain some of it, and the explained part, the explained deviation, is the difference between what we predict and the mean. So that portion, notice instead of observed minus mean, like the total deviation, it's predicted minus the mean. That is the portion that we can explain of that total deviation from the mean. We can explain part of it here with this particular explained deviation. And then there's a part we can't explain, and that is the difference between what we observe and what we predict. That should make sense, that if you're taking what you observe and you're taking what you predict and there's a difference there, that's the unexplained part. It's going to be easier to look at this in a picture, so we'll do that in a second. But note that when you have a model for an observation, actually I'm going to go ahead and skip that and go and look at these deviations. I probably have those out of order a little bit because we talk about this total, explained, unexplained deviation, and here's a picture that shows that. So notice here that we have an observation. That's our observed point. Here we have the mean line. And the difference in those two is the total deviation. Now, of that total deviation, part of the reason that we know that that observation is way above the mean, part of the reason is because we have an x variable that predicts for us a value that is above the mean. Our x value for that point is right here, and it predicts that we will be above the mean. And so for this particular x, we're going to be above the mean. So we're explaining in part why we are above the mean. Notice that's the difference between the predicted and the mean. So that's the explain part. But then there's a leftover that we didn't explain. We knew that the point would be above the mean, but we didn't know it would be that far above the mean. So what's left over there is the unexplained deviation. So let's take a look at that actually in our data set. We can obtain some of those values. I'm going to look at observed and predicted and residuals. Well, it turns out I told you that skin model gives you a lot of stuff. One of the things that it gives you are the residual values, and one of the things it gives you are the fitted values. Fitted values is what R calls the predicted values, and residuals, it's the unexplained deviation. So unexplained deviations are known as residuals. So what I'm doing here is I'm going ahead with the original variables we had, and I'm going to add 2 to our data. That's what the little data frame command's doing. I'm going to add 2. I'm going to add the predicted, and I'm going to add the residual or the unexplained part. So let's go ahead and get that, and let's look at it. So now we can see that we predict, for instance, for that first state, Alabama, that we predicted a 192 for the mortality, but it was actually 219. I'm not going to keep saying each time that this is per 10 million people, but it is. So 192 we predicted, but it was actually 219. And so we're off by 27. That's our residual. And so you can see that some states have higher residuals. Here's one here with a residual of 43, Delaware. Okay, Delaware, we actually have mortality of 200, which is substantially above what we'd predict. And so it has a large residual. By contrast, if I look down here a ways, here's New Mexico. I actually predict from New Mexico's latitude, I predict 141, but it actually has, or I'm sorry, I predict 180, but they actually have 141, which is about 39 per 10 million people less than what we predicted. So the size of the residuals really tells us, relatively speaking, how good our model is. We already know we have a good model. So these residuals, relative to our predictions and relative to our observed, these residuals are actually quite small. I know that because the model was quite strong. We were able to account for, if I recall correctly, actually I don't need to recall, I can go look at it. It was about 2/3 of the variation in mortality rate I could account for through knowing the latitude. So these are relatively small residuals. Okay, I think with these values, there's more that we can do with these values, and there's more that I'm going to do, but I think that I will stop here and leave that for the next video.